Today I'll be going over the formal mathematical notation that Bocconi tends to use in exercises and also in definitions and theorems. So the first thing we have is the difference between r squared, and rn. So r just indicates that you're dealing with one variable. So generally we would call it x. R2 would be two variables, Rn would be n variables, and so on. So for R2, they might call the variables x and y, or sometimes we'll use x1 and x2. And then Rn is any number depending on what n is. So the reason this is relevant is because it tells you how many variables you're dealing with. So specifically with functions, depending on whether you have r or r2, you can tell if it's a one or two variable function. So for example, if we're talking about r, we can say that the number 5 belongs to r. So this symbol here means belongs to or is an element of. And when you're dealing with r, you're just dealing with the number line. So you're looking at just real numbers, so just single numbers. While with r2, we could say that, for example, 2, 5 belongs to r2. So since we're dealing with r2, that means that we have two variables, so two axes, so this would be the Cartesian plane, and that would just be a point somewhere over here. And with Rn, we can't actually visualize that very well because that would be n dimensions. But the point is you could have many numbers depending on whether it's R3 or 4, etc. So you might have like 2, 5, 7 in R3, for example, or 3, 4, 5, 6 in R4, and so on. So as I was saying, this E kind of symbol means element of or belongs to. And if you have a line through it, it means does not belong to. So, for example, we could say that the number 5 does not belong to the interval 7, 9. And when you use brackets, that means that the numbers near the brackets are included. So in this case, 7 and 9 were included. While if you had used parentheses, that would mean not including or excluding. And sometimes you use a combination. So sometimes you might use parentheses and brackets when you want to include one number but not the other. So anytime we're using brackets or parentheses or a combination, that implies that we have an interval. So intervals are only going to be possible for R1. And by the way, whether we write R or R1, it's the same thing. So an interval is just any list of numbers, any set of numbers on a number line. So you cannot have an interval in R2. And if we had something like maybe 5, 7 with a slash of 6, this here means excluding or without. So on a number line, you could represent this by taking everything from 5 to 7, including 5, so you can make that a closed circle, and 7 is an open circle, and then also excluding 6, and just taking everything else. So because you're not taking all the numbers between 5 and 7, this would not be called an interval, it would just be called a set. So anything can be a set, but not all sets will be intervals. So only something very simple with no gaps in the middle can be an interval. And another way that we could represent this is by writing brackets 5 comma 6 not including 6 and then union parentheses and then 7, which essentially just means that we can have everything in this interval or in this interval, but altogether, again, this would not be called an interval. So this symbol means union, so essentially it means or, while an upside down U means intersection, which means and. So for this, we could have something like 5 comma 7 intersection 6 comma 6.5. The best way to simplify this is to look at it on a number line. And in this case, we have from 5 to 7 for the first one, including 5 but not including 7. And then from 6 to 6.5, including 6 but not including 6.5. So if you want the intersection, that would just be where they overlap. So the intersection would be from 6 to 6.5. Notice how 6 is included in both. 6.5 is included in one but not the other, so it does not satisfy both conditions. So we're going to include 6 but not include 6.5. And if instead you wanted the union of the same ones, you would take anything that's in either part or in both. So since the second part is completely included in the first one, the union here would just be the same thing as the first one. So from 5 to 7. Also, when we're talking about R, so when we're dealing with one variable, we can write that as x or x0 depending on what they use exactly. And when you're dealing with more than one variable, sometimes instead of writing out all the variables just because it can be lengthy to write out, sometimes they use vectors instead. So they might use x and make it bold, or they might take x and put a line under it. So this just means that you have many variables at the same time. So there's different ways of representing the fact that you have many variables. Another two symbols that you see pretty often are subset and strict subset. So when you have a subset, that's the one that's used more often. It's almost like a smaller or equal to sign. It has a similar meaning. So for this, you might have A, which is a subset of R. This just means that you have a set, which just represents an area or a list of points that is part of R. And because of the line underneath, that means that it could also equal R. So some examples for A could be any interval. So maybe 5 comma plus infinity. Or you could have A equal to R. So that just means that you're taking all the numbers on a number line. While when you don't have the line underneath, which is pretty rare, that means that it's a strict subset. So the only difference is that A has to be smaller than R. So it cannot be equal to R. It can only be something like the other one, or maybe you could have something like maybe 5 comma 6 union 7 to infinity. So this would not be an interval, but it is a set. So generally we use A to represent sets, which may or may not be intervals. And the reason that this notation is relevant is because they often use it with function notations. So when we have this notation here, which you see very often in definitions and in theorems, f represents the function. A represents the set, which is also called the domain of a function. And they're saying here that the set is part of R, so it's a subset of R. And then what you have on the right side here is called the codomain. So codomain is something that's always given. It's not the same thing as the range, but it is related. It just represents the values that they decide that you're allowed to consider for y. So basically the y values that the function is allowed to take. So in a minute, we'll see what that actually means. So this here is going to be a one variable function, because we can see that the domain belongs to R1 specifically, and the codomain also is R1. For the first half of the course, it's always going to be R1 at the end. So this just means that you put in one variable x and then you get one variable out, which is y. If instead we had A, which is a subset of R2, now that means that we're inserting two variables at the same time, x and y, and you still get one variable out of it. But when we talk about the number of variables of a function, we're specifically talking about the variables that are being inserted. So we're going to call this a two-variable function. So as I was saying, the codomain is not the same thing as the range, and they could possibly change this to something else, but they don't usually do that in exercises. But we'll see what happens when they do. So let's say that we take the function x squared, and you're told that you're taking the domain from -5 to 5, which belongs to R. That may or may not be written, it doesn't matter. And then you have a codomain, which is R. So even though x squared normally looks like this and then just keeps on going, this is specifically telling us that the domain is only from -5 to 5, including both. So that means that you're going to take only a part of this function. So something like this. So notice the difference, how the previous function was unbounded above, it kept on going to plus infinity, while now the function is limited above. So we could actually say that it has points of maximum and also a supremum. Then if instead we had the same function, and we're told that the domain is -5 to 5, and the codomain is from 1 to plus infinity. What this changes is that now we're only allowed to consider y values that are 1 or more. So at first the graph is the same. So again, we have from -5 to 5. But because we're only allowed to take the y values from 1 on, the function is going to be limited. It's going to be restricted by that. So it's going to look something like this. So it's really unlikely that this would ever come up, that they would change the codomain to something that's not R. But if it did happen, that just means that your y values are restricted, and so you have to take that into consideration. Then we just have a few more symbols. So first we have the upside down A. This means for every or for all. Then we have the backwards E, which means there exists. So generally we use this when we want to say that there exists a solution for an equation. Specifically, at least one solution. While if you have an exclamation point after it, it means that there exists only one. So it's more specific. So this one is used very rarely. It only comes up in one specific theorem later on. And then you have the backward z with a line through it. That means there does not exist. So this is used when you have no solutions. Then a few more things. We have, when we use these squiggly brackets with x0, we saw these before as well. These are used when you're looking at specific points, so not when you're looking at a whole interval or a set of points, but maybe just 1 or 2 points. So this just means a single point x0. As I mentioned before, if x0 is bold, or if they put a line underneath it, then it's still going to be a point, but it has many variables. So this would be an R, and this one instead would be an Rn or R2, depending on the exact situation. And as I mentioned before, we have A, which represents our set, which for our function would also be the same thing as a domain. The range, which is the y values that you get from your function, they're represented by f of A. And if instead you have A with the line, which is also sometimes written as A with the C either above or below, these all mean the same thing, so they mean complement, which is just the opposite of A. So everything outside A. So for example, if we have A, which is given by 2, 4, on a number line, that would mean everything from 2 included to 4 not included. And if they ask you about the complement, so A with the line or A with the C, that would be everything besides these points. So that would be everything before 2, not including 2. So that would be from minus infinity to 2, not including 2. And then we use a union sign and take everything from 4 on. Since 4 was not included before, it will be included now. So that would be from 4 to plus infinity. Also, whenever you have minus infinity or plus infinity, we always use parentheses since you can't actually include minus and plus infinity since they're not actual numbers. And one more thing that you're going to see is the empty set. So it's a 0 with a line through it. And it just means nothing. So for example, if you have 2 sets, so maybe again 2, 4, and then 6, 8, and they ask you for the intersection. Again, the best thing to do is to visualize it on a number line. So we have A, which is from 2 included to 4 not included, and B, which is from 6 not included to 8 included. So since they don't actually have anything in common, they don't overlap, we would say that the intersection does not exist. So we can either write that as the backwards E with a line through it, intersection of A and B, or we can say that their intersection is equal to the empty set, meaning that it's equal to nothing since it doesn't exist. And if instead they wanted the union, we would take everything that's in either A or B or possibly both. So that would literally just take A and B with a union in between. So that would be 2 included to 4 not included, union 6 included to 8 included. So those should be all the symbols that you're going to come across. They are really important to understand since many of the exercises use symbols to give you information. And also in the definitions and theorems, you're generally expected to write everything formally with the mathematical notation. So ideally you want to understand these right away so that the definitions and theorems will make more sense when you study them. Let me know in the comments if you have any questions or if there are any symbols that you